Let's look at part B of the question. Part B of the question says, the woman decides that to assist her in her everyday expenses, she will withdraw the interest as soon as it has been added. So she invests Y dollars at the beginning of each year based on an interest rate of 5% still. Show that at the end of n years, she will have received a total of this amount in interest. So now I'm interested in interest. So let's see. Let me do likewise, just like how I did part 2, okay? For the woman, part B, beginning of the first year, she invests Y dollars. Since I'm interested in the interest, so now I'm going to write down, right, the interest received. Right, for first year. That will be, since only interest, that will be 0.05Y. Then beginning of second year, what happens? She also invests another Y dollars, but just that she always withdraw the interest as soon as it has been added. So beginning of second year, she should have Y plus Y. The amount she invests at the first year plus another Y that she added in. So now interest received will then be, for the second year, will be 0.05 multiplied by this Y plus Y, which is multiplied by 2Y. So now at the beginning of third year, again once the interest has been added in, she remove it. So that means I should only have this amount plus another Y that she newly added in. So that will be a 2Y plus Y. This is added in. So this is 3Y. So my interest received will then be (0.05) multiplied by 3Y. So now let's see whether we can deduce any pattern. I'm interested in the interest received. Interest received for first year is 0.05Y. Second year, 0.05 times 2Y. Third year, 0.05 times 3Y. So can you see a pattern? When it's first 1 year, it's just Y. Second year, 2Y. Third year, 3Y. I think the pattern is quite easy to see, right? So here I can deduce that interest received at the end of nth year will simply be 0.05 multiplied by ny. So show that at the end of n years, she received a total of 1 over 40n times n plus 1y. So that means total interest will be, after n years, will be 0.05y plus 0.05 times 2y, the interest at the second year, plus 0.053y just at the third year, plus all the way you will expect to have 0.05, oh sorry, so you will expect the last one to be 0.05 and y. So now if I look at this, again I must see whether they follow any pattern. So I have y becomes 2y, 3y, and y, etc. If you see I factorize out the 0.05 y, then I will have 1 plus 2 plus 3 plus perhaps 4, should be 4, right? Then plus dot 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 all the way to m minus 1 plus n. So what kind of series is this? There's a common difference of 1, right? So here I have a series with a common difference of 1. So it must be a AP because there's a common difference. So I can apply AP formula. Since I'm interested in sum, AP formula sum of n terms equals to n over 2. You can use first term plus last term. So first term is first term, right? A plus last term Okay, let me rewrite this, alright? First term plus last term. So Sn equals to n over 2 first term plus last term. Of course, you can use the other formula n over 2, 2a plus n minus 1 times d. But since I know the first term and last term, I might as well use this formula, which is easier. So this gives me a 0.05y, first term 1, last term n. Divide by times n, which is number of terms. N, number of terms, there are n terms here, divide by 2. So 0.05 divided by 2, that gives me a 1 over 40. So I have shown part B.